Thank you for joining me. Welcome to TJ's Maths Clinic. In today's presentation, we are looking at this question sent in by one of the fans. This is GC 2025 Elective Mathematics. This is question 14 from Vectors and Mechanics. Question 14 reads, given that XYZ is an isosceles triangle with vector xy equals to vector yz, and P is the midpoint of xz. We are asked to express yp in terms of yx and yz. B, if vector xy is 2 column 5 and yz is minus 6 column 12, we are asked to find correct 2dp yp. Let's look at how we can handle this. This is from Vectors and Mechanics. Let's write down the solution. We have to apply triangular law of vector addition since we are talking about an isosceles triangle. So suppose we have a triangle like this. This will be the same. And since what we have y as common here, that's the reference point, then y will be the origin here. So we have y, then we move to x, here will be x, then z. Our movement from y to z can be accomplished in two ways. We can move from y to x, then x to z, or y to z. That's the shortest distance. And we are taught from the question that P is the midpoint of xz. Very important concept. Since length, let's say uh, length vector yx be equals to a, then vector yz be equals to b. Since since yx and yz are of equal length, it means they will have the same magnitude but different direction. So it means the magnitude of vector A will be the same thing with vector B, given that A will not be equals to B. Very important. They'll have the same magnitude, but they can be in different direction. Very important. Okay. Since xz now, the midpoint is P. So vector xz relative to the original is the same thing as saying z minus x, z minus x, z minus x. Very important. And if we say yx, it means x is a and z is b. So we have b minus a relative to the original. If we say vector yx is a, yz is b, it means x is a and yz is b. Let me represent it again. From here, z is b, then x is a. So we can see clearly that, let me move here, that vector xz will now be equals to b minus a. Very important concept. Okay, so since this is the case, we know that P, let me clean here, since we are through with this, this P now, vector P is nothing but, it will be half of xz. It will be half of vector xz. That will be the midpoint of xz. And x is A, then z is B. So it means P now will be half of what? Half of A plus B. Since xz is A plus B. Very important. Again, yp now, we're looking for yp. Vector yp now will be equals to P, vector P now minus vector y relative to the original. Since y is the origin, in this case, y is the origin. So the position vector of yp will be vector p minus vector y. Very important. Let me clean the first part of the question, or let me clean the drawing so that we can move up here. So it means yp now, vector yp will be equals to p, vector p is half of a plus b, then minus vector y, which is the original, will be 0. So yp now will be half of vector a plus b. Very important. And we have established the fact that vector a is nothing but yx, y to x. So yp now, vector yp now will be half of a, which is yx, plus b, which is yz. Okay, since a is vector yx and yz is b. So it means vector yp is nothing but half vector yx plus vector yz. So this will be the solution to question A. B, let's move to B now. Since we know yp now, let's move to B. Let me clean here so that we can look at B. Question B now said, if xy is 2 column 5 and yz is minus 16 column 12. Here what we have is yx, not xy. So we take it means to find yx is going to be the negation of xy. It does in opposite direction. Okay, so it means since we have x, to find xy now, and we know yz, we just take the negation. Okay, so since yx is equals to minus minus xy, and we have xy, it means yx now will be the negation of this xy. So yx now will be minus 2 minus 5. So this will be our yx. Okay, so let's substitute now to find yp. Our yp will now be equals to yx plus half of yx, yx, vector yx plus vector yz. So yp now will be half of let me use square brackets. Our yx is minus 2 minus 5 plus yz. Yz is giving us minus 6, 12. Let me put it in square bracket this way. Okay, so yp now, vector yp now will be half of, we add this I to I, j to j. You know, this is I and this is j. So it will be minus 2 plus minus 6, that will be minus 8. That will be minus 8. Minus 5 plus 12, that will be 7. That will be 7. Very important. Let's check again. Minus 2 minus 6 is minus 8. Minus 5 plus 12, that will be 7. So finally, yp, vector yp now will be half of 8, of course, is minus 4. Then half of 7 will be 7 divided by 2. So this will be vector yp, because we are asked to find vector y, the magnitude of vector yp rather, the magnitude of vector yp. So this is yp, so we have to find the magnitude of this vector now. So to achieve that, this yp, vector yp, we can write it as minus 4i plus 7 divided by 2j. So to find the magnitude of yp now, it will be the square root of minus 4 square plus 7 divided by 2 square. Very important, okay? Let's use our calculator to achieve that because we are asked to leave our answer to 2 dp. Minus 14, minus 4 square is 16 plus 7 square is 49 divided by 2 square is 4. So let's divide 49 by 4. We have 16 plus 12.25. We have the square roots. Looking for the magnitude of vector yp now. The magnitude of vector yp now will be, we add plus 16. That will be the square root of 28.25. The magnitude of vector yp now will be the square root of 28.25. That will be 5.32 units to 2 dp, to 2 decimal. So this will be the magnitude of yp, 5.32. First, we have vector yp as minus 4 colon 7 divided by 2. So we have to find the magnitude of these vectors. After, the magnitude is nothing but 5.32 units. So this will be the solution to this question. Thank you for watching. Please do share this to your learning colleagues. And don't forget to subscribe to TJ's Maths Clinic for more interesting videos. See you in my next video.